This is a power supply board that was removed from a Viewsonic VP211b monitor. This monitor was manufactured in 2004, and I have several of them. The model number of this power supply is ADP-60BF. I made a video about repairing the Viewsonic VP211b monitor with the emphasis on the power supply board, and pointed out that the most common failure is the big cap here, this 150 microfarad 400 volt. I've made this video because I've learned more about this card and some common failures that you might encounter. If you need information about how to disassemble this monitor and gain access to this board, well, you should check out that video. In this video, I'm just going to be talking about the power supply board itself. Now again, in review, this capacitor here has a very high failure rate. Now this one's already been replaced, but this is what they look like, the bad ones. I got a couple of them here. They'll have this brand name on them, Tycon, and they just fail with an atrociously high frequency. Now, sometimes they'll basically look normal, but if you look here at the end, you'll see this material dripping out of the terminal. If you check it with a capacitance meter, it'll read 0. Here's another one. Oftentimes that pin will just literally just fall out. Here's one, it's actually swollen. And this one got so overheated that the plastic actually started peeling and falling off. That sometimes happens when you have a very high ESR. These things can become incredibly hot, and it'll cause discoloration of the board. You notice here all this brownish discoloration here, caused by the heat that this thing put out. So the most common failure by far on this board is this capacitor right here. So if you have one of these Tycon capacitors on this board, I recommend just go ahead and replace it, even if it hasn't failed yet, because it's going to. Just a terrible, terrible capacitor. Every single one of these monitors I've seen, this capacitor had failed. Other possible failures, these two caps here on the output. These capacitors, C52 and C53, these are both 650 microfarad, 25 volt capacitors. These capacitors will develop an elevated ESR. I've seen that happen. And it causes the output voltage to drop. You get kind of a sawtooth waveform and the voltage will go down. But the one I'm most concerned about, and the one that cropped up recently, flip the board over. Now this whole board is being basically driven by this chip right here. This is the pulse width modulator chip. This chip is called the DAP008. And it's made by ON Semiconductor. But it'll just say DAP08. Now, I recently had failures related to this chip. Now, ordinarily, I wouldn't make a video about an isolated failure, but I got 3 of them in a row that all looked very similar. And it was driving me crazy. I couldn't figure it out. Now, the output voltage, which comes out here, which we can measure here, had dropped. It wasn't 0, and the board was still working, but the voltage had dropped significantly. I couldn't figure out why. Now we have a PDF of that chip, and kind of your typical pulse wave modulator. The signal output is here, and it drives that transistor, which drives that transformer. And then it's got a couple of feedback signals. And you got one called feedback and one called current sense. Now the feedback signal, now what it does is it samples the output current and then it sends it back across using this optoelectric coupler. And that feeds a signal back into the feedback. And this basically tells this chip to either speed up these pulses or slow them down. If the voltage is dropping, then it's going to increase the frequency of these pulses and then push up the output voltage and vice versa. But now we were getting an abnormally low voltage right here. So what's going on? Because I have more than one of these monitors, I can take the power supply from a good one and compare it to one of the bad power supplies. This is especially helpful if you don't have a complete schematic, which I don't. So I will start out with the good one, and we will be looking at signals with an oscilloscope on the good one. The power supply board in these monitors is a separate board, and you can actually test it independently of the rest of the monitor. We can plug in AC current, and I'm going to take my oscilloscope probe, and I can ground it here. This will be cold ground there, or output ground. And I can flip the switch and turn it on. Now the output from this board can be measured right there at that point. Now on the oscilloscope, we get a good solid 24 volts. Now that's the normal board. Now I have 3 abnormal boards that are measuring anywhere from 6 to 12. Now the voltages are constant on the bad boards. There's no sawtooth or anything. It's just a nice flat voltage, but they're just way too low. I have it grounded to the input side on the full wave rectifier there. We're just going to sort of poke around here and see what we can find. We look at the output of our pulse width modulator, but you can see those are our pulses coming out of the chip. And that's what's driving our transformer. It's running at around about 160 hertz, I think. Now we'll look at the feedback signal. About a volt. Okay, this is the kind of feedback signal we get when it's operating normally. Now we can look at a bad one. You see our output pulses are now at a fixed rate. They're coming much slower, about 33 hertz. Look at the feedback signal, and it's more like 6 volts. So the output is feeding back the information to the chip, telling it that the voltage is too low, and it needs to pick up the pace, but the chip isn't responding for some reason. So we go back to our PDF file on this chip, and can we figure out why the heck this is happening? Now, when I first looked at this diagram, I figured it's got to be some sort of a bad feedback signal, or maybe the chip itself had gone bad. But boy, when chips go bad, they either fail completely or they don't fail at all. They don't sort of fail halfway. That's kind of an unusual thing. And then to have 3 of them happen all within days of each other, what the heck is going on here? Here we have kind of a block diagram of that same chip. The chip is actually powered off the high voltage, off that great big capacitor. This is 160 volts coming in here. And then it's got this thing called VCC, so it's got somehow it generates the internal VCC by taking it from the high voltage, although it doesn't really tell you how. All it does is draw a line here. And then I got to thinking, I wonder if this could be a problem. So I go back to this diagram, and then I notice this little capacitor right here, which I had ignored at first. I figured, well, that's probably not important. Turns out it's very important. So let's look at that signal. So we decide we're going to look at pin 6 on a good power supply. That's VCC on a good power supply board. Pretty steady signal. Now here's pin 6 on a bad power supply board. What a crazy signal is that? Crazy sawtooth waveform. As a result of this abnormal voltage on the VCC, the chip just isn't working properly. And it isn't responding to the feedback signal. It's putting out an abnormally slow pulse rate and thus dropping the output voltage. So where exactly is that capacitor? Well, it's this little tiny guy right there. A little 22 microfarad capacitor right there. And as far as I can, it appears to be called C5. So why don't we just pull that out and see what we can find out about it. Now I've gone ahead and removed that little tiny capacitor. Hook it up to our ESR meter, and what do we get? Holy smokes. ESR greater than 40 ohms. It basically, it stops at 40, doesn't go any higher. So this capacitor has completely failed. Now here's our replacement capacitor. Oh, that's more like it. 22 microfarads, 2 ohms. Okay, we've gone ahead and replaced our little C5 capacitor. Let's go ahead and hook it up and see how we did. Now we have it, we have the output side grounded, and we can check our output voltage right at this point right here. Okay, now we'll go ahead and test it. Perfect 24 volts, exactly what we were looking for. Okay, it looks like that little capacitor has fixed the problem. Okay, we'll look at the output pulses on our chip. That's what we want to see. And the feedback signal, about 1 volt. Since this capacitor turned out to be bad, I figured I should probably check all of them. And sure enough, this one is also bad. Abnormally high ESR. This is a 47 microfarad, 50 volt capacitor. When this capacitor was failing, it was probably putting out so much heat, it probably damaged these two capacitors. Now, even though the board appears to be working normally now, I'm going to go ahead and replace this capacitor anyway. You don't want to leave a known bad capacitor in the circuit. I've taken our power supply board and I've mounted it back into the VP211b monitor. Okay, now we're going to see how we did. Hit the power button. Got a nice green light. Ah, there we go. It appears that we were successful. Excellent. Okay, so what lessons have we learned about the VP211b monitor and its ADP60BF power supply board? Well, we know that this big capacitor fails with very high frequency. So much so that if you have the original Tycon capacitor, you should probably just go ahead and replace it, even if it isn't bad yet. When it does go bad, it may exhibit signs of temperature overheating, including discoloration of the board or even peeling of the plastic. It may show swelling. It may show material leaking out of the positive terminal, or even the positive terminal just falling off altogether. Now, if this capacitor goes bad, the monitor will be dead. It won't do anything. C52, C53, these can go bad. They can build up ESR, in which case you'll get a voltage drop, but kind of a sawtooth waveform. In fact, in this particular board, I've already replaced them. I put 1,000 microfarad caps in here. They seem to work okay. We also know that this little capacitor here can fail with pretty high frequency, this C5, this little tiny 22 microfarad cap. The failure may be related to excessive heat being put out of this when this capacitor is dying. Now, if this capacitor goes bad, you're going to see an abnormally low voltage on the output, but the voltage will be steady. There won't be a sawtooth waveform. It'll just be a flat voltage. Also, this capacitor can also go bad, probably for the same reason, the overheating. However, when this one goes bad, it doesn't seem to cause anything to fail. But, you know, you should replace any bad capacitors when you find them. Okay, I hope that helps you.